So we're going to do some harder stuff here. It's going to look hard, but it actually isn't. Okay, we're going to differentiate root x. Scratch the old head, hey, how are we going to do that? Well, isn't root x just the same as x to the half? So if I just started with differentiating x to the half, wouldn't that half come down the front? And then what's in the box would be that subtract 1, just like the pattern. What is a half minus 1? Minus a half. Okay, fair enough. Which is a half multiplied by, well, the negative sends it down the bottom, and a half is a root. Okay, let's tidy that up. So the derivative with respect to x of root x is actually 1 on 2 root x. Not that hard. We're using index laws, negative powers, fractional negative powers, and just the basic rule. Same thing here. That's really hard until you just go, well, that's y equals x to the minus 1. So again, you'll notice the different terminology I'm trying to get you used to. There's different ways of asking the same thing. Here, it's what's the gradient function. So here, there's my function. So my gradient function could be dy dx. Now, the negative 1 is going to come down the front, and then it's going to be minus 1 subtract 1, which is minus 2. So therefore, dy dx equals the negative of 1 on x squared. Done. Calculate the slope of the function, oh my gosh, where x equals 1. How silly does that look? F of x equals, okay, that's going to be x to the 3/4 plus 6/5 multiplied by x to the minus 3. So I haven't changed anything. I've just rearranged it so I can apply that rule. Okay, so I need the gradient function. So the 3/4 will come down the front. 3/4 x, and it's 3/4 subtract 1. Okay, the minus 3 down the front, so it's going to be minus 18 on 5, x to the minus 3 minus 1 is minus 4. Let's just tidy that up a bit. That's going to be 3 on 4, and that's going to be the quartic root of x. So it's underneath because of the minus, and it's a quartic root because of the quarter. I'm sorry that those two 4s are together. I didn't mean for that to happen. And this will be minus, that's a ridiculous minus sign, 18 on 5x to the 4. Now our question was, well, that's their gradient function, but we want the slope where x is 1, so we're going to go f dash 1, 3 on 4 minus 18 on 5. I have no idea. 3 on 4 minus 57 on 20. The fractions aren't the hard bit, so just use your calculator. That's just to show you that it doesn't matter what it looks like. It's actually not that hard. Ooh, one more, promise. Okay. Clearly this is simplify first. X to the 3rd plus x to the minus 2 minus 2x to the minus 2/3 on x to the 5 on 4. I'm definitely going to use my calculator here. Y equals. I'm going to put that by itself, and then that by itself, and then that by itself. So I'm going to leave them there. So the black one is going to be x to the 1/3 minus 5/4. If I cared, I'd do that manually, but I don't. Plus, and now I'm looking at the minus 2 minus 5 on 4, which is x to the minus 13 on 4. And then it's minus 2, x to the something, minus 2/3 minus 5/4. At minus 23 on 12. You know, I can't be really bothered to change that. That would be y equals 1 on x to the 11, and it's going to be the 12th root. It's not really about that. This video is to show you it doesn't really matter how hard it looks. Don't be put off. It's just index laws and then applying that really, really simple formula. Go to it, go hard, because these aren't, I've titled this harder stuff, but trust me, these aren't hard. We've got to get through these and then on to some more challenging stuff.